Hey guys, tonight we are going to be looking at finding the product of special polynomials. So these ones are just special because they have a unique pattern to them that all the other ones don't. There's two types of patterns, sum and difference patterns and square of binomial patterns. So those are two. Now you're going to try and describe the pattern in this essential question, okay? The sum and difference pattern is the one where you have the same numbers, but an addition sign between one and the subtraction sign between the other, and then they become a squared minus b squared. That means that first number squared plus that second number squared. Oh, sorry, minus that second number squared. And the square binomials, there's two of them. One that when it says variable plus number squared, the other one variable minus number squared, okay? And here's their pattern. We're definitely going to want to remember these. We're definitely going to want to remember these again when we are working on our examples. I'm just going to take a quick little screenshot of that so we have that when we work on our examples. All right, example time. You guys ready? Here we go. The first one. Is this we have number, and then a subtraction sign and an addition sign between this. So this is that sum and difference pattern. Our sum and difference pattern goes that first number squared minus that second number squared. First number squared minus that second number squared. So first number squared, x squared, minus second number squared, 4 squared. Because these are both 4s and these are both x's, okay? X squared minus 4 squared is 8. So this is just the pattern that it has. Could you continue to use that box or FOIL method? Yes, you would get the same thing. Let me show you really quick. Again, I like the box, the rectangular array, x minus 4, x plus 4, x squared, 4x, negative 4x, negative 8. These two are like terms and cancel out. And what do we get? The same thing that we got up here. Okay? Just trying to be efficient. We're just trying to be efficient with these special ones here. Okay. So this is also a sum and difference. B and B, positive 10 and negative 10. They're opposites of each other. So we'll have b squared minus 10 squared. Or you can, again, use the box, the rectangular array, or the FOIL method. So b squared minus 100. Done. Except I forgot my square sign. All right. Example 3, plus minus, everything else is the same. So 2g squared, parentheses are super important for this one, minus 5 squared. So g is going to be squared, but also 2 is going to be squared. Minus 25, 4g squared minus 25. If this was complicated, what I was just talking about, again, you can use FOIL, or you can use that rectangular array. Too many A's. And you will get the same thing. This is just more efficient. All right, let's move on to our next set of examples. Now we are looking at this one where it has plus a squared, minus a squared, minus squared, plus a squared. This is that second one, square of a binomial pattern, square of a binomial pattern. When we have a square of a binomial pattern, we have this that we can use as our outline. Or again, we don't have to memorize anything. We can just use that rectangular array or that FOIL method and just solve it to what we talked about yesterday and the day before. So, this one says plus. That means we're going to have, I'm going to write this down, a squared plus 2ab plus b squared. A squared, w squared, plus 2w times 2 plus b squared, 2 squared. So w squared, I'm just going to go through and simplify, plus 2 times 2, 4w plus 4. Done. Or you can remember, again, this says w plus 2 times w plus 2, rectangular array or FOIL, w2, w2, w squared, 2w, w, 2w, 4. Combined, w squared plus 4w plus 4. Same thing. Not bad, right? All right, when it says minus in between them now, we're going to look at this minus one. We're going to do, we'll go back, and we're going to change this sign right here to subtraction. Okay. X squared minus 2x7 plus 7 squared. X squared minus 14x plus 49. Done. Again, the array or FOIL will get you the same thing. 6. This one says minus as well. Now we're going to do 3y squared minus 3y times 7 times 2, forgot that 2, plus 1 squared. 3 squared is 9, y squared is y squared, minus 3 times 7 times 2, 14 times 3. 14 times 3. 52y plus 1. Again, please use an array or FOIL if this is getting too complicated. It gets you the same thing. It'll be okay. It just won't be fine. Last but not least, number 7. I'm going to put 7 down here in green. This one says addition. So now we're going to do 5z squared plus 2 times 5z times 4 plus 4 squared. Everything, remember those exponent properties, gets squared. 5 squared is 25. Z squared plus, multiplication doesn't matter what order you do this in. 2 times 5 is 10 times 4 is 40z plus 4 squared is 16. Done. Again. You don't have to do it this way. I'm just trying to help you guys see that there are special ones. These are all considered special, okay, because they have a pattern to them that the other ones do not. Now let's go ahead and practice with a real life problem before I let you do those on your own problems. Each of 2 dogs has 1 black gene, capital B, and 1 white gene, capital W. The diagram shows the possible gene combinations of an offspring and the resulting color. What percentage of the possibility gene combinations result in black? So black is 2 capital B's, and what is that? That's a 25% chance, because that's 1 out of 4. 1 out of 4 options. Okay, 4 ways that can happen. 1 out of 4 ways. 25% chance. All right, the gene makeup of an offspring can be modeled by binomial plus squared. So product of binomials, this is a special one, okay, because it has that square sign. Use the square of a binomial pattern to model all possible gene combinations of the offspring. So when it says plus in between and it's that squared, we do 0.5b squared plus 2 times 0.5b times 0.5w plus 0.5w squared. Let's simplify this because it's a little bit complicated right now. 0.5 times 0.5 is 0.25 b squared plus 0.5 times 0.5 is 0.25. 0.25 times 2 is 0.5 BW, those have to still be there, plus 0.25W squared. Use a square of binomial pattern to model the possible gene combinations of offspring. So the possible gene combinations of offspring are a 25% of B, which is B squared, okay, a 50% chance, 50% chance of BW, which is gray, and a 25% chance of W squared, which is WW, white. Done. We modeled it. We use that, our Punnett square is now modeled in an equation. Why algebra? Because now we can plug things in. All right, here is your on your own problems. Go ahead and pause the video at this point. Resume when you're ready to check your answers. Here's what we should have gotten. What are the patterns in the special products? Okay, those are those algebraic expressions that were listed above. So just rewrite those algebraic expressions, okay? For this, let me go back and I'll show you the algebraic expressions. So the essential question is this, this, and this. There's 3 of them. All right, I hope you guys are having a good day. Go take that checkpoint.